Hi and welcome to this video for the BTEC Applied Science Level 3 Unit 1. So we're going to be going through some more of the mathematical calculations, as you can see there. Being able to calculate quantities of masses for substances reacting or produced using balanced chemical equations, moles and molar mass. And then basically the same with solutions afterwards, of being able to calculate quantities of concentration for reactant substances using moles and volume. So the bottom one you'll definitely be doing on your Unit 2 as well in terms of titrations. So both of these relevant to Unit 1 and Unit 2. So just going to do a few examples of each, much easier to see. So calculate the mass of water required to react completely with 5 grams of silicon chloride. So we're going to be using the equation moles equals mass over mR. Now if I want to work out the mass of water, well I know the mR, I can look that up, 18. But I need to know some information about the number of moles. So how can I get the moles? Well, if I look at the chemical equation, for every 1 mole of silicon chloride, it needs 2 moles of water. So if I try and find out the number of moles of this chemical, then I can just double it and find out how many moles of water are required. And then I'll have moles and I will have mR. So let's see what information we've got about silicon chloride. Well, I know the mass, and in terms of the MR of it, if I just get my calculator, 32.1 plus 35.5 times 4. So 174.1 for the MR there. So let's start working through this. 5 divided by 174.1. And that gives me 0.0287 numbers afterwards, and that is moles of silicon chloride. It's always worthwhile writing things out for the examiner so that they know what your numbers actually mean. So 0.0287, I'll just keep the calculator function since I've got that next to me here. And if I times by 2, and this gives me the moles of water. Should have probably given myself a little bit more space for this. But now that we know the moles and we know the MR, I need to rearrange this equation to work out mass. So mass equals moles times MR. So if I know my moles of water, multiply it by 18, which is the MR. So I'm assuming you can see the moles, you can see the MR. So therefore mass equals 1.03 grams of water. So on to the next one. Calculate the mass of phosphorus required to make 200 grams of phosphine by the reaction below. The ratio you can apply anywhere within these equations. You can compare to reactant, you can compare reactant to product, product to reactant, any which way. So that's why a balanced chemical equation is very important for these. So if I want to work out the mass of phosphorus required, then first off, across my product here, I need to know how many moles I'm wanting to make, because then I can look at that 1-to-1 ratio that we've got here. And I know however many moles of phosphine I want, that's the same amount of moles of the phosphorus that I require. Let's see what we've got. 200 grams of phosphine. So moles, mass over mR. So I want 200 grams and phosphine, 31 plus 3 for that, 34. 200 divided by 34. 5.88. So on calculator. Moles. Great. Now what I would do is I would just show the examiner that I understand what this ratio means. I would say a 1-to-1 ratio. Therefore, 5.88 moles of phosphorus required. Now, for that then. So if I know my number of moles, and I know the MR of the phosphorus here, then I can work out the mass. So mass, moles times MR. I've got my 5.88, so on, that I want, times the MR. So P4, remember to take that into account. So 31 times 4 gives us 124 for the MR. And that equals 729 grams, just to round it off. So fairly big mass required for that. Now the final one. 25 cubic centimeters of a hydrochloric acid solution required 20 cubic centimeters of a 0.1 molar sodium carbonate solution to neutralize it. Calculate the concentration of the HCl. So we're going to be using the equation N equals C times V, or some rearranged form of that. So if it's asking me to work out the concentration of the HCl, C equals N over V. Well, I know the volume, I've got that there, but I don't know the number of moles. However, I do know the volume and the concentration of the sodium carbonate. And if I know those two, I can work out moles. And if I know the number of moles of this, and because of the ratio, 1-to-2 ratio, if I double it, that will tell me the number of moles of HCl. So let's start working through it. Now, so there's one little thing that I'm missing here. The unit is in cm cubed. You must always remember to convert it to dm cubed so that it matches the unit here. So 20 divided by 1000 and then times by 0.1. And that gives us an answer, if my mental maths is right, 0.002 moles of sodium carbonate. Now, ratio. So for every 1 sodium carbonate mole, it will take out 2 HCl moles. So I therefore need to double this. 0.002 times 2 of HCl. Notice that I'm always writing what I'm referring to with these numbers. Makes the job of the examiner much easier, and if you do that, they tend to be happier. And happier people are more likely to award marks. So now, final bit, concentration. I know the number of moles. Over 25, but again, remember to convert that. So 0.04 divided by 25 over 1,000. And that gives us an answer of 0.16 moles per decimeter cubed. So that's what it means by the reacting quantities, being able to work out how much of either another reactant that you need, or how much of a product you would produce, or if you wanted that much product, how much reactant you would need. And this is more or less the same, just in terms of solutions rather than solids. Thank you.